So let's start. This lab 2 will be on digital image processing. Okay. You have your uh, lab manual provided to you. So I'll summarize the content and show you in MATLAB how to do everything. So try to focus and try to understand. If you have any questions, you can let me know. Now, digital image processing, actually the first of all, the image format. The images that we have comes in different format. It can be like a JPEG image or .png, okay, or in the vector format .svg, .tiff, different formats. Okay, these are actually compression techniques. Different compression techniques to store images. Now, the raw image can be like 20 MB, 20 megabyte. But when you compress the image into one of the format, so it will becomes like 1 MB. Let's say it is in the .png format, it will become 1 MB. If you are using JPEG format, it will become 0.5 MB. So you compress the image to reduce the size of the size of the image. Okay. Now there are how these compressions work. This is not within your syllabus, so you can ignore those portion. But we'll need this format, the format name, when you try to work with the images. Okay, you need to check what is the format name. Otherwise, you will not be able to work with the images. Achha. Now you see, when you have an image, it comes in three different formats. It can be a binary image, it can be a grayscale image, it can be a color image. Am I clearly audible? Binary, grayscale, color. Now, when you have a binary image, the values means an image is nothing but a matrix. In your MATLAB, you have a matrix of values like this way. So what can be the value of this range? What is the range of these values? Based on that, you have this definition. So in a binary image, all the values are from 0 and 1. 0 means that is black color, 1 means that is white color. Okay, so when you have this black and white image or binary image, you can only see two colors, two different colors. I'm going to show you, wait a little bit. So if you look at your lab manual, you can see there are three different images. From left to right, you can see in the left side image, the color is clearly visible. Okay. The image of Lily. Now, in the middle image, you have the same image, but now you don't have the color information. But all the objects are clearly visible here. And if you look at the last one, you see there is only two different colors. One is black and one is white. There is nothing else. And when you have binary image, you see this petal information here. The information here in the petals, these things are no longer available there. You can barely see those things in the when you convert it into a binary image because you have just two numbers, 0 and 1, to represent the values. So come back here. In binary image, you have just two values, 0 and 1, to represent everything. Okay. So for instance, in this matrix, if I do it like this way, 0, 0, 0, 0, 0, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0. On the outside, the image will look something like this. Inside that is the value matrix value. The equivalent will be something like this. On two sides you have this black. On the middle you have this a small white portion that is coming from this one segment. Okay, so I hope it is clear. Now moving on to the grayscale. You see in the grayscale you just widen this range, the range of value you can actually accommodate. So instead of 0 to 1, you make it 0 and 255. This 0 means you're pure black, and 255 means you're pure white. Okay. And in between, you have this 0 to 255, you have this wide range of shades, 256 shades of white. Okay. So if it is close to 0, like 1, 2, 3, 4 values like this, it is more black, okay, more darker color. If it is close to 255, it is more like more whiter in color, okay, more brighter in color. So that's the difference actually creates. And in when you have this kind of image like 256, we call it a grayscale image. Now you can ask this question, why 256 in particular? You see, we are using here the number format UINT 8. UINT stands for unsigned integer. Unsigned integer 8. So this is a number format used in MATLAB. 8 stands for 2 to the power 8, that is equals to 256. That's why you have. It means that if you have any number like 270 in this format, UINT format, it will be chopped down to 255. Sorry. The maximum value it can be represented in this number format is 255. You cannot represent more than that. And unsigned means it is only positive. Signed means it can be positive and negative both. So this 256 value is actually enough to represent all the information that you have, that you need. So if you look at this image, when you look at this grayscale image, you can see whatever information was there in the color image, all the information like where is this like leaves, where is this petal, where is this flower, where is this portion, all the small portion are clearly visible in the grayscale image. So in a grayscale image, it is very clear, like all the object information is intact. Only the color information is not available. So using just 256 value, it is enough to represent everything. So object information is enough to represent in a grayscale image. That's why we use 256 values. What will happen if we use just normal double format? The problem that will happen, that is actually the memory overloading. It will take too much computation time. You see an image, you will see a little bit later, an image consists of lots of pixels. And when you start to process the image, it is time consuming. And if you use double format, okay, large format that can actually hold more numbers like UINT 16 or 32. So these number formats are huge. You don't actually need that much information to represent an image, and that will be redundant. So this will be redundant. So we don't need that. That's why we don't use it. Okay, to make the process faster. Now that's about grayscale image. Now, if I move to color image, a color image is also known as RGB image. It stands for this red, green, and blue. So each of these red, green, blue, these are called channels, 3 channels. What are individual channels? Individual channels, all of them individually are a grayscale image. Red, that's the grayscale. Green is a grayscale. Blue is a grayscale. All of them are combined together, merged together in an RGB image to provide this color information. So this one, 3 channels, is like a 3D matrix. A grayscale image is like a 2D matrix, like this way. And in RGB image, you have 1, 2, 3, 3 dimension. In the third dimension, you have this channel information, red channel, green channel, blue channel. Okay. And when you combine these 3, you get this color information out. Okay. That's the concept. That's the basic concept. Achha. Now, in the RGB image, Normally, when you have this color information, it is actually just for visualization. Okay, the color information is for our visualization, better visualization. But when you try to work in image processing, any kind of processing task, you usually don't need this kind of color information. You need this object information because that's why the processing actually required. So you can actually, whenever we work with image processing, we mostly work with this grayscale image. We don't work with color image. We don't need to. Okay, I hope it's clear. Any question? Now, forward. So now the question is how to actually import an image in a MATLAB. Okay, if I want to work with an image, how to import the image. So MATLAB has a function that is called imread. Okay, that means read an image into the MATLAB. So inside you give a variable name like image. Imread. What is the image that you have to provide the name of the image. Achha. Now there is some image that is actually stored in MATLAB. You can work on these things for default. You can also work with an image from your laptop as well, from your personal images. Okay, you can also work with those things. So let's work with something the MATLAB already provides, like cameraman dot .tif. The file comes in a TIFF format. So you have to name and take care of the format as well. So if you do this image cameraman dot .tif, you will see an image of a cameraman will be appearing. Sure. So if you look at this one, if I write I1 equals to imread cameraman dot .tif, and if I run this section, use a MLX file, okay, live script to actually represent those things. Now, if you see here, when you are reading this image, everything is coming in the matrix format. This is your output. Okay, so the image is read into the MATLAB. If I put it here, so do you see this is a 256 by 256 UINT8 matrix. So the image actually a 256 by 256 image. And you can see the value. These are the pixel values. And you can see all the values are within the range of 0 to 255. There is no value greater than that or lower than that. Because you see, this is a UINT image. You can see here, UINT, that means the maximum can be 255, the maximum value available. Now, after reading the image, you can show it. I give a section word using the IAMShow function, image show, that will show the image. What is the image I want to show? Okay. So you can see this is the image actually. Whatever the value you had here, it represents this image in other way. Okay. So this is actually interesting because you see whenever you have a digital image in the processor, you have nothing but just numerical values. And when you combine this together, you get this beautiful output. Okay. This image you can open a new window. And you can see this is your image. Okay. Let's try another image. I2 is equals to imread yellow lily. That's a JPEG image. Okay. And I am show I2. Now, if you first look at this matrix, you can see for I2, this is 1632 by 161224 multiplied by 3. So this is a three-dimensional matrix. Previously, this was a 2D matrix. So this was a grayscale image. Now you have a 3D matrix. That means this is a color image. That's how you understand. And you can also see it from here. Okay. And the হ্যাঁ হ্যালো হ্যাঁ ওয়ালাইকুম আসসালাম বলো হ্যাঁ হ্যাঁ বলো 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 তাড়াতাড়ি আমি ক্লাসে আছি একটু আচ্ছা, ওটা একটু পরে কথা বললাম, আমি একটা ক্লাসে আছি তো, একটা সময় আমাকে ফোন দিও। তারপর আচ্ছা। Okay. So if you look at this image now, I2, this is a linear image, the image that you showed earlier. So this is a 3D image, okay, or an RGB image. Acha, now let me, so you see we have learned about two functions, I am read and I am show. So if you use this one, I am read, this will read the image into MATLAB. If you use this one, this will display the image. You can see the image using this I am show function. Acha. Now, careful about one thing. If you say, for instance, want to use an image from your like from your PC, okay. One thing you have to care about is the directory. Okay. Acha, let me show you. See, if I want to load an image from your from your local PC, these two images are already saved in MATLAB. That's why you can actually access it. But you see here, this is your directory. If you want to মানে, use an image from your local PC, the image should be in this directory, or you can also change the directory from here. Okay, you can see you can change the directory from here. So fix your directory whatever you want. That's your up to you. Now let's say I want to use an image. Section break. Let's I3 is equals to I am read. I want to read an image. So if I go here, I want to read this ping file. Okay, this ping image. So I write this way. And you can see already the suggestion is coming. bmx.png ping I am show I3, because this image is located in this directory. I have put the image in this directory. So if you have the image in a different directory, you just copy it and place it in this directory. Then you can actually see the image. Okay, so if I now run this section, so now you can see this is your image, and this is also a 3D image. Okay, 3D image, and you can see the output. So be careful about the directory, otherwise you will be trying, but you will not be able to access the image. আচ্ছা, Now, now, so import the image, and one thing you have to be careful about the directory. Always keep it in your mind. আচ্ছা, you should try to do it simultaneously in your own laptop. If you face any problem, you can let me know. Okay. আচ্ছা, now we are done with import. Now see, when we are importing the image, some of the image was coming like this way: 1320 multiplied by 1000 multiplied by 3. This type of things. Acha, what does it mean? So this one is the channel information. If it is 3, that means this is a 3D image or an RGB image. And if it is 1, that means it is a grayscale image. And if it is 1, we don't mention it. Acha. Now, if you look at this one, what is this? This is the width and height of the image. Okay, width and height of the image. And this is also called the resolution of the image. Okay, so the resolution of the image is this. When you ask, the resolution of the image is this. And these are, you see these small values, like I give here, these small values, each and every values in the matrix. We call them pixel value. Pixel value. So the pixel is the smallest, like the smallest measurement. When you actually uh, represent an image, pixel is the smallest value. Okay, so 1320 means multiply 1000 means there are in total 1320000. This number of pixels, this number of pixels in that image. Okay, so if you have only 101 by 100 image, that means there is only 10,000 pixels in the image. Okay, so so that means the resolution is this. So in this image, the resolution is higher. In this image, the resolution is lower. Now, it may ask the question, does it mean that the resolution is lower? Does it mean this image is low quality, this image is high quality? That's not actually right, because you see, the quality of the image is controlled by many other things. The resolution actually represents the information, the number of information that is available in the image. A higher resolution image will have more information in it. Okay. So the pixel values will represent have more information. If lower resolution image means there will be less information. But the quality of the image depends on many other things, like what are the sensors that were used to capture the image. Okay. What are the contrast? Okay. What is the light level? Okay. Many other things. Now, this pixel value actually represents the intensity of light. Okay, the pixel value represents the intensity. So when you have, like in the matrix, when you have something like this, like 2, and here you have 150, that means the intensity here is lower. Here the intensity is higher. Intensity lower means this will be darker. This will be more brighter shade. Okay, that's what is represented by this pixel values. Is it clear? Now, so your task now is to import an image in your MATLAB. Okay, import any image. It can be your image from your personal laptop, personal PC, or the image that I showed. Import the image in your laptop, in your PC, and show it in the comment section. Just upload your take a screenshot and upload it in the comment section. Let me see if you're working or not. You have 2 minutes.
Lily or the cameraman wants.
Yes, a little bit louder, please. I cannot hear you.
Sir, can we show the cameraman once?
Yeah, of course. Take a screenshot of your window and show it. Only two. What about others? Anyone else? সবাই কি বসে আছে? এতক্ষণে তো হয়ে যাওয়া উচিত। আমাদের ক্লাস পারফরমেন্সে মার্ক আছে না? You have extra marks from class performance. If you don't perform in the class, how should I give marks? Okay, now let's try to look at something more. So see, if I use this function IM tool, you can see here, you can read here, view and explore images. IM tool, let's say I3. Okay. If I run this section, this image will open this one. This is called a image viewer app. Okay. This is called a image viewer app. Now there are many apps available in MATLAB to work with images. I'm going to show you several of them. So this is the most easiest one to understand. You see, image viewer app, what does it show? Besides showing the image, also give you the information. You can see on the left corner, pixel information, XY and RGB, red, green, and blue. So if I put it here, you can see the location. On the left side, you have the location and also the values of the pixel values from different intensity. So you can see here, you have 244, 143, and 109. And if I move towards the black region, you can see the pixel value is 38, very closer to like more closer to zero. And this one completely zero because this is zero. It is completely black. So if you go to a more lighter portion, you can see the pixel value is increasing. If you go to a darker portion, you can see the pixel value is again dropping. So you can see from this image viewer app, what are the exact pixel values for different regions directly. Okay, so this is the benefit. So try to understand these things. Also, you can see from the tools, there are many other things that we can do from here, like crop image, measure distance from two different pixel values. Also, image adjust contrast. We'll look into those things later. So there are other things that you can do as well. This is one thing. Try to actually play with these things by yourself. Now, this is one thing. Another thing, there's session break. Another function, IF info. Okay. This actually provides the information, the metadata about a graphics file. So if I run this section, you can see this is providing a structure will fails. So the data type is actually a structured data type. That is one of the data type like before, like you have table data type, categorical data type, cell data type. So this is another kind of data type that is called a structure. It shows the shows the values like this way. On the left side, you have the field name, and the right side, you have the value. So you can see that is the file name, that is the file modification date when it was modified. Okay, it was modified or created in 5th September, okay, 2023. That means I took this image September 5 last year. And also the time is also available. You can see the file size, that is the total resolution. Also the format, the width and height, color type. Okay, lots of different information are available here. Now, let's come to our stop sharing.
Sir,
Yes, follow.
sir, if we are using our own picture, then it's showing something like you'll be using IMRead file try does not exist, but I renamed the file in try. This one.
Can you show me your yeah, you can share your screen. Let me see the error.
Sir, I think you have to pause your screen before I'm sharing.
And share start. Okay, try now. Hmm. Okay, what is the try dot? Tarpor, you have to have some. What is the image? Go to that image.
The image is showing.
What is the format? You can see the format. What is the format of
JPG.
the image?
It's a JPG.
So you have to write this one
I
as well,
tried
right?
JPG, tried also.
Try dot JPEG. You have to write this one as well. So you have to mention the file format. Now try. Wait, it is running. You can see it is. Why it is running for so long?
So it's
Okay, that means your directory is wrong. What is your directory? I cannot see your directory here. Open your original MATLAB directory. Go to your original MATLAB folder. Original MATLAB.
okay,
Original
sir.
MATLAB page. Go to the actual MATLAB page. That means the first page that actually appears in your MATLAB. I can see it there.
So,
Close it. Hey, you can see that's your directory E. Then IUT 6th semester 4606 lab 2. Not that one on the
yes,
left
sir.
side.
Sir, I
Sixth
couldn't
semester.
get you. Sir, the file is in that folder also.
Acha. Zoom in your location. Zoom in.
Sir, do I
Local
need
disk.
to copy it in the T1?
No. Lab 2. Try. Why it is not coming there? Lab 2.
The file is in different directory. It's 4606.
Oh, yeah, check. Check again. Yeah, it is 4606. It should be 4602. Your original directory is given in 4606. In your MATLAB, the original directory is given as 4606. Not this one. The other one, you can see on the left side, Yeah, that is. You have to change
sir.
this directory. Change it to 460 to lab 2, then it will come. Now you can actually right click on it. You can right click on it. You can have all the images there. Not this one, the below one. You have to run the below section, right? Try.jpg. This one.
Oh,
You're
sir.
running the wrong section.
So I think it will show now.
Yeah, it will show now.
Thank you, sir.
Okay. You can stop sharing your screen. Just be careful about your directory. It should not be any problem. Okay. Acha. Now, let's talk a little bit about image conversion. Acha. Now, image conversion, you see, sometimes we want to convert the RGB image to a grayscale image, or like a grayscale image to RGB image, or binary image. We can see different conversion. It is actually very simple to do in MATLAB. Alhamdulillah. You have some built-in function, like for instance, RGB to gray. Okay. The function written in your lab manual. Okay. If you look at your lab manual, this is IM to PW or IM to grade. This is, I think, a little bit older function. Okay, MATLAB updates the function with different versions. So just check your MATLAB documentation, you will find it. I think the most recent one is RGB to gray. Okay, so if I use this one, you can convert a RGB image to a grayscale image. We usually need to do that. So how does it convert? RGB has a 3 channel, right? And in grayscale, you need only 1 channel. So like I said before, this red, green, blue, all of them are actually individual grayscale image. So when it converts to a grayscale, you just take an average. I don't, whatever the red channel value is, it multiplies with some value, like I think 0.2 or something, plus 0.6 into green, plus 0.3 into blue, something like this. I don't exactly remember this exact ratio, but it summarizes this way, averages all the values, pixel values, and gives an output as the grayscale image. So if I do it here, see, if I do it here now in our MATLAB, so let's go to section break. So I want to convert this one. So let's say I3 gray or star gray. So RGB to gray, okay, of my I3. It will convert it, and I want to show this image. I am show I3 gray. So you can see, first of all, this I3 gray. Now you see here on the left corner in your workspace, your I3 is 1080, 1920 multiplied by 3. So it was a RGB image. Okay. Now, when I convert it like this way, you see the channel information multiplied by 3, that is gone. The resolution is remaining the same. Only the channel information is gone. So now it is a 2D matrix. So it is a grayscale image. And you can see this is the grayscale image values. Okay. And if I look at here. So this is your grayscale image. Now you can actually use another function, section break. It's called montage. Okay. Using this one, you can actually side by side compare two images. First we have the function, then inside a second break. First inside the function, then inside a second bracket, I3, comma, by I3 gray. Okay, if I run this one, now you can see side by side two images. Let me zoom it out. So you can see these two images. This was your red, the RGB image. This was your grayscale image. Okay. I believe it is clear. So remember the montage function, we'll keep working on it again and again. And you see, when you are converting this RGB to gray, all the information, like the object information, here is the object, there is the object, all the object information is clear. Okay. You are not losing the object information. Okay. You are only losing the color information. If I try to convert it into binary, let's see, binary, I3 bin. So it is I3. Okay. Now, so you see I3 bin, and if you look at here, this is showing logical. It is no longer saying EYNT8, that it is saying it is logical, because in binary, you have logical values, 0 and 1. That's why it is telling you that it is a logical logical values. Okay, no longer EYNT8. Now, if I want to section break, if I want to use this montage side by side, I3 gray, comma, I3 bin. So if I look at here, now you can see this is your RGB grayscale and this is your binary. And when you convert this image to binary, you can see on the our Baymax here, most of the information is gone, because I'll talk about more about how to they actually convert into binary. But this is what happens when you represent using binary. You have just two information, white and black, and most of the regions is just completely turned black here. Acha, I hope this is clear how to convert an image from one type to another. So this is your image conversion. Okay. Then now we can actually do lots of things in MATLAB with images, and we'll be doing a lot of things using images. And you see, when you actually do this operation, any arithmetic operation, we try to do those things using any arithmetic operation. You have to do any arithmetic operation, we do those things using the grayscale image. And there can be some other operation as well, like you may want to like rotate your image. Okay, these are very simple thing. You can do it very easily. Like you have the functions, built-in functions here. So I am resize. Okay, it will resize your image. Okay, I am crop. This will crop your image. Then I am like rotate. Okay, this will rotate your image. Or then I am transform. This will actually transform your image from one side to another, one side to another. Then you have I am right. So see, when you actually convert an image to grayscale like previously, you can also save the image in the grayscale format using this I am right function. So all of them inside have some parameters. Check the documentation, write the name and check the documentation. It is very easy. For instance, if I use I am right, you have to give the original image. Let's say it was I2. I wrote it as I3 bin. Okay, comma, this is the original file name. Then I want to, what is the name I want to save? I want to save this as, let's say, Baymax binary dot JPEG, whatever the format I want. So first one should be your file, should be the original name of the file or of the variable. And the second one is the under what file name you want to actually save it. So this way it is work. Okay, so these are the operations. These are different operations. There are many other operations. You can do those things very easily. Let me show you one of them at least. Achha. So now if I do it like this way, I am rotate. Okay, what I want to rotate? I am to rotate this grayscale image or this RGB is fine. And so see, if you see here, just always use the documentation. You don't have to memorize everything. You just use the documentation to find it. You can see this is the rotating function. And you can see what he's saying. So I am rotate I. The second parameter is angle. What is the angle? How much angle you want to rotate? Okay. There are many other things. There are many other things. You can also read those things by yourself. Okay. And if you go in the in the bottom, you can see there are many other functions available as well. Okay. I am rotate 3. That is for different types of volumetric. We have not talked about volume. Okay, that's actually an MRI image, which actually volume as the third dimension instead of color. That's another thing. You don't need it. So if I write I am rotate dot 30, okay, and run this section, let me, and I am sure, let me first, I3 rot is equals to this, I am sure I3 rot. Okay, now you can see the image has been rotated. Okay. Okay, so this has been rotated by 30 degrees. Now, one of the problem when you rotate the image, you see some of the information is just gone. Okay, that's why the third parameter was there, method, how to actually take care of this one, that portion that is actually getting outside the image boundary. Now, here one thing, important thing, you see, there is something else we can do. Instead of changing the value one by one again and again, there is an interesting thing you can do. You just remove this one. Okay. See in the top one, in the live editor, you can see this control option. Click this control and you can see some of the different options there. First one is numeric slider. Let's put a numeric slider there because I want to change it and see different changes like 0, 1, 10, 20, 30 easily. So I click this numeric slider, make it. What is the minimum value I want? 0. What is the maximum value I want? 30, 60 degree. What is the step? 10. Okay. Now, if I run this section, you can see now it is 0. Okay. Now, if I change it, it is now 10 degree shift, 20 degree, 30 degree, 40 degree. See, if I use a numeric slider this way, we can very easily do lots of things and without writing the code again and again. Now it is 60 degree. Now let's put him 180 degree. Okay, now you have see your image is completely rotated. Okay, into 180 degree. You have a complete 180 degree rotation like this way. So this way, you can actually do a lot of things, and putting the slider like this way makes your task very easily. Okay, so just to repeat, you have to go to the control section, the numeric slider. It will open these values like this way. What is the minimum value you want? What is the maximum value you want? And what is the step? Okay, using this, you can actually do it like this way. I hope it is clear. Okay, now just take an image. Okay, take an image as input and try to resize it. Okay, I am resize. There is I am resize function. Take an image as an input, some other images than this common images, something from your own PC if you have, and try to resize the image using I am resize function. And you will see if you look at this I am resize function. This one. So I am resize function. The first input is your image. The second input is your scale. How much actually you want to resize it. Okay. So for this scale one, put a numeric slider there. Okay. For this scale one, put a numeric slide like this way and show the output. Okay. Show the output and show the output in your taking a screenshot and put it in the comment section. Okay. So that I can see. You have 2 minutes. I will do it.
Sir, in the slider, what minimum value will use?
কারো হয়নি? Anyone? Sir, can you convert RGB to gray and have said we use our color. Does this mean we cannot convert it back to RGB image? I am sure I am resized. Okay, একজনের হয়েছে. Anyone else? Should it be 10? The resize shouldn't it be in the point region? When you resize, I think am I audible? If you resize, it should be from the range 0 to 1. Okay. It should be from 0 to 1%, like this way. How much you are actually resizing. Yeah, it is fine. ID 337, it is fine. Anyone else? Anyone else? Only one. What about others? It's a simple thing. Are you facing any problem? Acha, to answer 317, can we convert RGB to gray? So color information loss, can I convert? Okay, yes, grayscale to RGB. Exactly, we cannot convert, but we can convert grayscale to RGB. So in general, you see, like I said, the conversion from RGB to gray is like multiply each value with 0.3, like this way. So when you convert grayscale to RGB, you can make all the channel value as like 100, same values. That will also do, that will give you an RGB image, but not an exact replica. Okay. So completely exact replica from grayscale to RGB is not possible, but RGB to gray is possible. And I hope you got your answer. Now, আচ্ছা, so আর is only 337 শুধু একজনের এটা কোনো কথা হলো?
Sir, my laptop gone hang.
হ্যাঁ, ল্যাপটপ কি হয়েছে? হ্যাং
Sir,
করছে?
hang হয়ে গেছে Zoom আর MATLAB detection.
আচ্ছা, পরে করিও তাহলে। Others keep do try. Okay, it's a very simple task. You should be able to do it. আচ্ছা, now let's come. So we have seen some of the basic things about image, how to work with images, digital images. Okay, you know how to input an image, how to visualize the image, how to do some very basic operations on the image. Now let's try to do something very important. It's a very important topic in image processing that is called thresholding. Okay, this falls under the image segmentation type. Image segmentation. Achha. Image segmentation is actually a very important topic, and it has lots of applications in different domains. And there are different ways to perform this image segmentation. Okay, lots of different ways. Now, this includes in biomedical system, biomedical imaging. Okay, in one of the application we'll see a little bit later. So this image segmentation has lots of different applications in different domains, and there are different ways to do it. One of the ways, a simple way, is to perform thresholding. So this is what we are trying to, we'll try to see now how to perform thresholding. Now there are other ways that you can do image segmentation as well, things that that a little bit beyond your scope. Okay, for instance, you have this edge segmentation, edge based. This is pixel based. This is actually edge based segmentation, and this requires filtering operation, filtering or convolution operation, something that we'll learn in the DSP course. Convolution is convolution. So I am actually not including those portions. These are a little bit outside your topic. So we'll only focus on this thresholding part. Okay. Acha, 347. After you resize, can you show the output? 347. Show the output using a montage function so that I can compare what is happening there. Acha.
Yes, sir. Trying, but laptop is
Yes, I cannot hear.
sir. My MATLAB is sometimes not working. It's creating problem. Sir, if I get the output, I'll show you.
Okay. Acha. Now, when it comes to thresholding, acha, let's look at this one first. You see this image, this one here. I have explained those things in the left side. You can read those things by yourself later. You see, in a wall, there is a crack there. Okay, this black portion is the crack. You can see this white portion. This is your like the normal wall, and there is a crack there. So you want to know what percentage of the wall has a crack on it. First of all, you want to know whether there is a crack on the wall. The second of all, you want to know what percentage of the wall there is a crack in that in that image. So that's called segmentation. Segmentation means separating the image into different regions. Okay, separating the image into different regions. That's called segmentation. And when you have this thresholding, the idea is you will separate the image into, for basic level, two different segments. Separate the image into two different segments. This is called, one side is called foreground, another side is called background. So like previously you saw the Baymax image when you convert it into binary. So the Baymax was like the white side, that's the foreground, and everything else was black, that was the background. So that's the idea. Whatever image you have, the object that you want to focus on, that should be in the foreground as white, and all the other things should be in the background as black. So that will separate the image, divide the image into two different regions. And something like this, we want to do it here. To identify the crack, we want to, the crack portion that you can see, we want to make it like white or black, the rest of the things as white. So that way, you can actually segment the image into two different sections. Okay. I hope the idea is clear. Let me show you. So see this image. This is what I was actually talking about. Whatever the image that you have here, when I do it like this way, you can see, you can exactly see which region is the crack. Okay, the crack portion is marked as white here. So from this image, you can see that this percentage, like 10% or 15% of the image has a crack on it. So you can say 15% of the wall has a crack on it. So if you actually capture the image of a crack. So that's what is our purpose actually. Segment the image into 2 or 3 or 4 like this way, different regions. Okay. Achha. I hope the idea is clear. Let me show you first. So this thresholding, okay, is for segmenting into regions. Different regions it can be. So one side we call it, when you have two, one side we call it foreground, another one is background. Okay, whatever your ROI is, ROI stands for region of interest. Okay, you want to put your ROI in the foreground or background. So one side should be your white, another side should be your, based on your application, like this. Achha. Now this has, you can see from the one, if you can do it using image processing, you can say, so the wall, how much percentage of the wall has a crack. Similarly, let's say you are in a factory, producing mugs or jars or glasses like this way. Mug or jar or glass. Okay. হ্যাঁ সাকিব, হ্যাঁ, আমি ক্লাস নিচ্ছি, আমার দেরি হবে রে, আজকে মনে হয় যাওয়া হবে না, ক্লাস শেষ করতে করতে 2টা বাজবে। হ্যাঁ ওই যে এক্সট্রা ক্লাস মিস গেছিল তো শুক্রবারে, কালকে হয়তো বা টাইম হইতে পারে, আমি আজকে হবে না। আচ্ছা আচ্ছা ঠিক আছে। So you see, mug, jar, glass. So in the mug, so when you are a factory, there are hundreds and thousands of mugs that actually created, okay, are made there. Now, to check each and every individual marks or each and every individual glass manually is a very time-consuming process. However, if you can take an image of each and every one of the marks, and from the image, if you can actually identify whether there is a crack on the mug, that means there is something wrong with it, you have to change it, or how much percentage of a crack is in that mug. So if you can say if it is less than 5%, okay, we can actually work with it. We can actually change it or modify it and make it perfect. If it is greater than that, you have to remove it completely. Okay, you have to throw it out. So this way, you see, in different applications, you can use this image processing task, and you don't have to do it manually. Once I actually do it for one image or two image, you can actually like automate the process. After sometimes, you can actually automate this entire process, automate the process, and from just one, whatever you do in one image, you can do it for 1,000 different images. Okay, so we'll talk about those one a little bit later. Let's try to understand and look at the thresholding first. Now there are different ways you can threshold. The most basic one is called global thresholding. Global thresholding. Achha. So what does it mean by global thresholding? See, global thresholding means binarization. You want to separate the image into two different segments. How does it work? Let me show you. Let's say this is your image and these are your pixel values. This is 2, 190, 3, 230, 230, 201, 4, 69, 68, 98, 100, 120, 7, 60, 120, 140, 0, 40, 140. So if you look at these values here, you can see these 2470, these are very small values compared to the other values, right? So if you say there is a threshold is equals to 10. What does it mean? Anything less than 10, you want to put it and mark it as black. Anything greater than 10, you want to mark it as white. So you see, when you use this binarization, you can convert your image into binary now. That's how binary image is formed. You find a threshold, and whatever below that threshold, you put it to black. Whatever greater than that, you put it to white. So now you have 0. So everything is converted to 0 and 1. That's how you binarize. So when you binarize it, you have this binarization process. You're converting the image into foreground and background. One side is white, one side is black. That is called thresholding. And for our crack image, if you do it, so say whatever a crack portion is, whatever the crack portion is, we want to make it black. And whatever the non-crack portion is, we want to make it white. Okay. So that's what we want to. That's what we actually want to do. So let's see in our MATLAB how we can do this. So I think I have to go to our MATLAB folder. Now, I think the crack image is here. So let's see. Our image IC is equals to I am read. I am read. So you have the crack image here. See, this is my crack image. Let's look at this one. I read the image, then show the image. I am show IC. Okay. If I run this section, you can see this is my crack image and you can see the value. So this is a 3D image. This is a 3-dimensional image. And these are the, this is the image that we are showing. Okay. So this is the crack and I want to segment this portion. Achha, I think I already have a file here. I already created a file here. So I think I have already provided a file here. You can actually work with this one directly. Okay, you don't have to do it. So image segmentation I have already seen here, show you here. So it will be much more faster. Achha, so let me show you directly here. So you see this is your crack file. Okay. And this is your image. This is another image of a crack. This is another image of a crack. There are 3 different images. I provided this file in your laptop, in your Google Classroom. You can see it from there. So these are 3 different images. I want to find this region of the crack automatically, not manually. So what do you have to do? After importing the images, you have to convert it into grayscale first. Okay, so you know the function RGB to gray. So you can easily convert all the images to grayscale. Okay, so I have converted those things. Now, global thresholding, for global thresholding, there is a function called IM_binarize. It will automatically find that threshold that will binarize the image, that will create 2 different segments. The values are calculated using this method, Otsu's method. You can look into those things as well. So if I do it, you see I am binarize this grayscale image. You have to do it for grayscale. It cannot work for RGB image. Any operation, grayscale image. So see, when I do this I am show, you can see this is the output. Okay. And if you look at it carefully, you can see here there is a small black portion here, very small, and here you have this entire like the crack portion. Okay, so you can see side by side, if I do this in the montage operation, you can see the crack portion is very clearly identified here. All the other regions are identified as white, and the crack portion is identified as black, and there is some noise here, a small noise. So if you do it for the second image, you see this is again, I have the crack portion very clearly identified, and this is the noise, some small noise. So whenever you are doing this image processing, some noise will be there. That's fine. There are ways to actually get rid of those noise pixels. We'll look into it later. So that is our grayscale image. And using this global function, it is automatically doing it. Okay, you don't have to manually calculate it. It is doing it automatically. Any question? Achha, I hope it is clear. Now, so you can ask the question, then what should be the percentage of the crack? You can see there is a function, number of this is 0 and 1, right? So in this one, in this image, if you find how many pixels have black or 0 value out of total number of pixels. So let's say if you have 1000 pixels, 100 pixels have value of 0, rest of the ones are 1. So you can say 10% of the image has a crack on it. So this way you can actually calculate exactly, pinpoint calculation. How many pixels out of total number of pixels have this black region? That is the crack portion. Achha. So I have written those things in your lab manual. You can check it from there also. Okay. So if you do it here, now one thing, find the threshold. So you can ask what is the value based on which this actually this binarization or segmentation is actually performed. So there is a function that is called gray_thresh that will give you the threshold value. So you can see for the first image, the threshold value was 115. So any pixel intensity value that was greater than 115, that was marked as 0. Anything lower than that was marked as 1, and anything lower than that was marked as 0. And this is done by this is calculated by the Otsu's method. Okay. So for the second image, for this one, this was 147. For third one, this is 128, like this way. Now, you can also, instead of relying on this value, global threshold, you can also do it manually. So you can see this I am binary function, same function. The second parameter that we have, the second parameter will be a value from 0 to 1. What should be the value you want to do? So if you do it like a slider like this way, you can see the variations there. One by one, you can see each of the variations, how it is actually working. Now, so this is called manual thresholding. Adaptive threshold is a little bit different. You see, if you look at this image, this is the rice image. Here you can, so let me show it from the original image. Rice. This is the rice original. Okay, if you look at this image, you see this portion and the top portion has a much more brighter region. It is more white, and the below portion is more dark. It's more black. Okay, darker region. That means the image contrast is not actually equal in different regions. It is different in different regions. So when it happens, when it is actually like that, the problem is, you see, you can find a global threshold like 20 or 40, but these regions, which is in the darker regions, they will not be correctly identified. See in the Google, see in this one, when I perform this binarization using global, this one, if you look at this one very carefully, in the top region, the rice grains are correctly identified, but some of this one, for instance, this grain, okay, this grain here, you can see it is not identified. Also, this grain is not correctly identified because you see it is the values that is calculated due to this darker shade is actually falling within this region. And you can also see some noisy pixels there, very small noisy pixels. We can actually remove those things as well. Achha. So when you have this kind of different like illumination throughout the image, different segments, global threshold will not work. You have to take help of adaptive threshold. So it will what adaptive threshold will done, what will do, you see when you do it like this way, you see this rise grain is now correctly identified. All the rise grains are now correctly identified in adaptive. So it will, for different regions of the image, it will find different segmentation value, threshold value. Then it will work. Okay. So you have the image given to you. You can actually try it by yourself and see how it is actually working. I hope it will be easier. Now moving forward, see you have this X-ray image. This is the X-ray image. Now, what can happen is that in some scenario, what can happen? So your image may not have just binary. You want to do it more than two segments, 3 or 4 segments. For instance, in this X-ray image, when you have this X-ray image, what you may want to do is this. This is the flesh region. See, this is the flesh region's outer border. This is the outer border, this is the flesh regions, this is the bone, then this is another region. So you want different. You see, each and every portion, if I do it using binary, so let me read this one from this section. So this is your original image. Acha. If I do it like this way, global threshold, adaptive threshold, you see what is out. If you use global threshold, this is the original image. It has been now have two segments. This is white and black, but you can actually see inside the X-ray, the purpose of the X-ray is actually lost because that's not what you want to do. You want to identify and segment different regions separately. Also, when you use adaptive threshold, it is not working either. So in scenarios like this, you want to have multi-threshold, like you want to separate the regions into 3 or 4 or 5 different segments. So there is a multi-thresh function that will help you do it. So let me run these things again so that we can see. So if I do it now, so if you look at this one now, right now, you see the last one, when you actually use the multi-level thresholding, now it becomes very clear. You see, this is the outer border, this is the flesh or the tissue region, this is your yellow color, this is the bone region. Then you have this one inside this. You can see some of the things that is actually placed inside the bone to actually have some operations, things like that. So now you can see you can actually separate these different segments out. And here, if you look at these values, you can see what are the different values are calculated. 54. So one segment, it should be 54 to segment two regions. One portion should be 147, like this way. So this way, you can actually use multi-level thresholding to actually do different tasks. Okay, based on the image, you may have to change it. For some image, your global thresholding will work. For some image, you need adaptive thresholding. It's you look at the image, try out different things, and see whether it is working or not. Okay, it works like this way. Also, you can also test it on a random image like this way. For instance, this horse image, I have tested it here. You can see how it is actually working. Now, this one, uh, when I binarize, you can see this horse region, horse portion is, the image looks very clear here, pretty cool here. So if you change the values like manual thresholding, you can get values like this way, extract these values like this way. Yeah. So take one image that you have, any image that you have, and try to apply this binarization. Okay, use manual thresholding like this way, sliding, and try to see if you can actually do it very nicely for your image. Try it on on one of the images that you have, whatever you actually prefer. Do it quickly. It is already 1:45, 12:45. Do it a little bit quickly. Any question? Sure. Yeah, it is working 3:47. So here you have first global thresholding. So for global thresholding, you have the IAM binaries function. Whatever you have, just put global here. Then manual thresholding. Okay, you have the same IAM binaries function. You have the image and put some value there. Put some value there, whatever you prefer, and put a slider. Then you have adaptive thresholding. You have the same binaries function value, and you just put adaptive here. And number 4, you have multi-level thresholding to separate the image using different differences. So you have a multi-thresh function. For this, I am quantize. It will quantize the image into different thresholds. Okay, so these are 4 different thresholding operation. Okay, now do it for one image and show me the image. Mm, করা হয়েছে? I have described everything in your lab manual, so you can, whatever I have said, it is clearly described in the lab manual, so it should not be a problem. You can study from there, read it properly. Anyone? হচ্ছে? You should be able to do it by now.
স্যার আমরা কি গ্লোবালটা দেখাবো নাকি স্যার চারটায়?
দেখাও, একটা দেখালেই হয়। যেটা হইতে করতে পারতেছো সেটাই দেখাও। হচ্ছে না? Okay, try it later. Let's need to finish this lab. There are many things actually still remaining. Let me, okay, do it a little bit later. Let me finish these things. First of all, check the documentation. Documentation of I am binarize. There are lots of things you can actually do it. Okay, you can actually try to check those things by yourself. Some of the operations is also there. Look at this one, for instance. If you look at this image, you see one side is very bright, one side is completely dark, and it is very difficult to read whatever is written on the left side. Okay, makes it very difficult. But you see, using this I am binaries function, adaptive threshold, but with some other parameter, like especially this one, foreground polarity, and you can see you can completely change the image. Now you can see it is very clearly readable. Okay, previously it is barely readable the left side, but through this kind of binarization, you can actually clarify it, clarify whatever is written there, very clear. So you can actually do a lots of different things using thresholding. Okay, it has application, like I said, it has application in different domains. So many things can be done. So try to look at this this one as well in the documentation side. Acha. Now, if you go to MATLAB, you see, if you go to MATLAB, yeah, 315. It is working nicely. You have the image completely black. Yeah, it's nice. Acha. Now, if you look at this apps region, go to apps, you'll see we are trying to understand how to work with digital images, and MATLAB actually provides different toolbox. We have already seen one toolbox, that is the different apps. We have already seen one app, that is the image viewer app. And if you go in your apps, there are many other apps for different purposes. Okay. Now, this one particular, we are interested in this one, image processing and computer vision app. Try to look at to this one, image processing and computer vision, and you can see what are the different apps available there. For instance, you have this DCOM browser. DCOM is a file format, okay, that uses MRI imaging. When you have MRI image, they actually comes in this DCOM format, okay. Also, you have this leader viewer, okay, and this one in particular, image segmenter. This is I am interested in image segmenter. Okay, let's click on this one, image segmenter. So there are lots of things we can actually do with this image segmentation. Let's try to look at some of them at least. Okay, you see on the left side, this is the image segmenter app. On the left side, you have this load image. If I click on it, load image from file or workspace. I want to load from workspace. And I want to work this one, the i3 gray. Okay. And I don't want to change the contrast first. So this was our image. The image was our Baymax. Okay. So what do I want to work with Baymax? You see, there are many operations on top of their left side. You have this morphology operation, define mask, add to mask, create mask, then texture. So there are many things you can do. Let me show you a little bit. First one, threshold. You already know what threshold is. I have not discussed graph card. That's another way of actually creating thresholding operation. Okay, segmentation operation. That is another way, graph card. So that is I am not covering right now. We are only interested in the thresholding, whatever you have seen. So whatever you have did in the code with the code, you can also do it like this way using this app. If you click on it, the threshold, you will see this one will appear, and this show binary will show you the binary one. So this is the binary one. Now on the left side, you can see this is the global threshold. So based on global threshold, this is your output. If you click on it, you can see there are other things like adaptive threshold. So adaptive threshold, this becomes very noisy. So this image does not require adaptive threshold. There is another one, manual threshold. This is more interesting. See, in the manual threshold, you can see this is the threshold value. You can change it. You can change it to high and see what happens when you make it very large. Okay, if you make it very large, it's becoming like this way. If you make the threshold very larger. And if you make it very slower, you can see it becomes completely, the image is destroyed. So let's say I want to like keep threshold, keep Baymax on. I want to keep my Baymax intact and remove the other things. Okay, so this is more or less okay. What about the global threshold? Global threshold, the value was like this. 125. Acha, let's keep it like this way. And you see this create mask, you click on it. So when you create mask, you can see in the host story, this is your original image and this is the whatever you see. This is called a mask because you're binarizing it. So in the original image, you are putting 0 and 1. That's why it is called a mask operation. Okay. You have the binary mask here. And based on this image, you can do a lot of different things. Okay. Now I'll show you a little bit, but you try to explore by yourself if you want to if you're interested. You see there are lots of things you can do. One of the things is called morphology. And what is written there? Refine segmentation mask. That's what we're doing. We're segmenting it and you can refine it. Refine it using different things. That is called morphology. Remember in the rice image, when you perform this segmentation, there are some noisy pixel values there. Using this kind of morphology operation, contour operation, other operations, you can actually remove those noisy pixels from there. Achha, let's take a little bit about this one. Look into this one. See, in the morphology, there are lots of different things like dilate mask, expand the foreground, and shrink foreground mask, shrink foreground holes. Then erode mask. Try to, whatever image you have, try to see the operation of different things by yourself. Okay, let's say I want to do this one, create this one. And see, whenever I create this one, you see this is what actually happened. The image changed, right? And so you see the shape that we're using is a disk shape. That means I am actually putting this shape throughout, running this shape throughout the image. So this is changing my mask. So the binary is like this. Now you can see we have this. If I increase the shape, you have keep increasing, you will have this one. You see, the purpose is dilating. Dilating is expanding the foreground mask. So it is making everything whiter. Okay. So when you are expanding it, you see everything is becoming more white and this black region is getting removed. Okay. So it is performing kind of like a filter operation over the image like this way. So let's close morphology. I don't want to do this. So this was your original one. Let's see another morphology operation. What I want to do, I want to erode the mask. So whenever I erode it, you see this regions removes the white portion. But now you have too much of it is actually removed. So I want to reduce it. Let's make the radius 2. Okay, now you have better this one. So now you like this. So let's make it 2. Okay, you see this portion is now actually gone. And you can apply this one. When you apply this one, this is now this is coming here. So close morphology. Now you can see this is your original image. This is the thresholding image. So show black. So this was the binary image that you got, and this was the eroded image with mask. Okay. So this way, using this morphology operation, you can actually do a lots of different operations on the image. Try to visualize those things by yourself. Try to work with those things the way you want. So for your image, different things it might require. It depends on the image what you want, what you are working on. For different image, you need different operations. So try to do those things by yourself. So if I do this flat fill, না এটা দেখেন নাই flat fill রাখে হচ্ছে just একটা জায়গাকে ভর্তি করার জন্য আচ্ছা we don't need it. So you can also you see this is segmentation. This was what we actually did here. You can create new segmentation if you want to do it again from different and from new. Okay. So I hope this is clear. This is your image segmenter app. Let me close it. Now, just like image segmenter app, you will see there is another app that is color thresholding app. What is color thresholding app? Click on this one. So this page will appear, color thresholder. This is a different app. And if you load an image, let's say I want to load an image from the workspace, the I3, I want to work in. So color segmenter, that means you need a color image for it. Okay. From the name, it is clear. So this is the color image. I want to take the color image of the playbacks. Now you see out after RGB, there are other things like HSV, color information. This is actually different color work with different colors. Like HSV stands for hue saturation value. Okay, so you can change the hue, the saturation level, the hue level in the image using this way. Also, there are other things like YCBCR, LAB. Let's look at this one. If I click on this one, you will see this one will distribute how the different things are distributed here. You see, this is the hue value. And if I click on this one, if I change the hue, you can see what is happening here. If you change the hue, this portion is becoming completely now. Yes, ekdom image নষ্ট হয়ে গেল. Let's keep it wherever it was. Very clear. And you can also do it like this way. And again, hue value, it is an important ingredient of the image, so you should not change it. Let's press it like before. You know. Acha, let's load the image again. Also, it is free. Now you see in the saturation value, if you reduce the saturation, you can see what is happening there. Okay, you can see if you change the saturation value, what is actually happening. This way, what you can do, you can take the color image, change the saturation value first. This will remove some of the things. And you see in the value region, this one, if you put everything there, now, you see our Baymax. Previously using segmentation, you were unable to identify our Baymax clearly. Okay, other things are coming. Now you can see if you change this one, only the Baymax is actually coming here because this is the Baymax region. Little bit of this white. So this is our Baymax. Okay. So you can export this one, export this image first. So this is all the things are already black. Okay. Now you can export this one, export this image, then perform the segmentation. Then try to remove these things. It will be much more easier to give you the Baymax portion out. Okay, like this way. It actually works this way. If I use this show button, it will look like this. Okay, so I hope you have the understanding, and you can also check with other things like ICBCR, different one, different values. So this is a little bit more this saturated like this way. Okay, so this is from your Y. If you put it like this way, you can see what is happening, how different things are changed. Okay, you can see how these things are changing. So let's keep our Baymax. So this is now our, so this way, okay, you can use this color thresholder here for different purposes. I'm just showing you, introducing you to these things so that you have some understanding. So I hope you have some basic idea. Share the screen on how to work with these apps. So we have seen the image viewer app, image segmenter app, color thresholding app. There are many other apps like region analysis. You will see one is region analysis. You can find the exact region, what is the area of a particular region. Using this, you can actually perform like what is the exact size of the object. You can also calculate those things from from this one. I'm not covering this one. You can also check it by yourself. Any questions so far? If you do you have any questions? Now, image histogram. another. So image histogram actually stands for like, I want to know how the pixel values are distributed. What does it mean? See, if the number of pixels, and this is the value. So, when you have a grayscale image, it starts from 0 to 255. So let's say this is 10, this is 20, this is 30, this is 40, like this way, 100. How many pixels have the value of 10? How many have 11? How many have 12? How many have 20? So if you look at the histogram, you can actually get this information that in which region most of the values, pixel values are actually located. This information is given you by the image histogram. So if you look at this MATLAB, this one, live editor section break. Okay. So if I say our IMHist function, this gives you the histogram of a particular image. I want to do the histogram of I3 grayscale. Okay. And if I run this section, আচ্ছা, if you look at it, you can see most of the values are located within this region. Okay, from this 30, 40 to 100. Most of the pixel values are located here. Some of the pixel values are here, but most of the pixel values are in this region. So based on this, you can get some idea where actually most of the pixels are actually located. What are the most of the pixel values have? What are the values of the most of the pixels? Acha. Now, what is the benefit of this one? You see, what is the benefit of this one? So far, we actually talked about mostly screen. Now, we have seen some of the operations, basic operations on the image. You also see an important part like the thresholding operation, image segmentation. You saw different apps, how to work with different apps. There is another topic that is actually image enhancement. Image enhancement. So in different operation, you might want to enhance the quality of the image. Okay. Sometimes your image has like very dark. You want to make it brighter. Okay. So sometimes you want to enhance the quality of the image. Okay. So sometimes you want to like the image is barely visible. So you have to do something to make the regions very clear. So this kind of image enhancement is also an important part of image processing. So there are different ways that you can actually perform, lots of different ways. Some of the very common one is like contrast adjustment. Contrast adjustment, then histogram equalization, then you have gamma correction. Okay, then you have filter operations. Okay, so then you have convolution operations, filter operations. Now, after this one, so these things are actually can be done very easily, and you can actually understand what is happening here. This filter operation, convolution operation, these things are a little bit advanced topics. Some things you don't have exact or proper knowledge yet to understand. So you don't have to worry about those one. In your lab manual, if you check, I have covered these three, all of these three. So gamma correction is very simple. Whatever the image value that you have, you just multiply it to the power gamma. Okay, this will change the gamma values. So the code and everything is actually given in the lab manual. Please check it by yourself. I need to finish this one and another time. So check gamma correction from your lab manual. It is very easy. Also histogram equalization, the function is actually already given. If you look at your lab manual, you see this is your gamma correction. You have the input value, whatever the value is, you just actually multiply it exponentially. Take the exponential of to the power gamma. And you can change the value 0.2, 0.3, 0.4. If you change it, you will see the image is becoming much more, the contrast image is becoming much more clear. So the image will become much more clear this way. And so that is your lab task. You try to do it after we finish this one. Try to do it, take an image and try to perform this kind of gamma correction. I have given you the code. It is very easy. One thing to careful about is whenever you actually do these operations, you should convert the image to double first, because in UINT8, you have the limit that the value can be maximum 255. If you don't change the value, you will have some wrong calculations, because if you have a value of 300, UINTA cannot represent 300, so it will be cropped down to 255. So whenever you are doing any kind of arithmetic operation, you should change the image to a double value, double format. Okay, very easy to do. You can try to do it by yourself. Also, when the image histogram, you see, whenever you have the image, after there is this IM adjust function, histogram equalization function, adaptive histogram equalization. So try to write this function on your image and see how it is actually changing the image output. For instance, if I try to do it in our case, let's see. So this is our image histogram, section break. So if I do histogram equalization on our I3 gray, you see, if I do it like this way, it is changing this type. So let me put it in the montage operation, section break, montage. So if I look at it side by side, you see this is what is happening there. When I equalize it, histogram equalization, so the black portion, everything, equalization means you are actually expanding the histogram. Whatever the region is, you make one side 0, make another side 255, expanding it so that it comes in the similar region. Now everything looks much more brighter. Okay, you have less black portion. So, so this kind of histogram equalization, then you have adaptive histogram equalization. That is another one. Let's put adaptive there. Adapt histogram equalization. Now you see, when you're doing this adaptive histogram equalization, this image is much more clear than this one. So it is working better. Okay, so there are different correction operations like image enhancement. You can check it by yourself one by one. If I do one more thing, section break, IM tool, I3 gray. Okay, so when I use this grayscale, you can see in the tools, this adjust contrast, okay, contrast adjustment. And you can see, if I change the contrast of the image, you can see the output here. When I do it like this way, what is happening? The contrast of the image, the black portions are become much more brighter. Okay, so you can change the contrast like this way and also reduce the contrast like this. So I am making this contrast, reducing it. You see, this portion is white, everything is becoming darker. Okay, now, okay, like this way, if you take this image, then try to perform binarization, it will become much more easier for you to segment this Baymax out. So there are lots of things you can do, image enhancement. So try to do it by yourself in the in your own images and see how different things actually works. Okay, I hope this is clear. And if you have any questions, let me know. Do you have any questions? Okay, so this is up to today. Okay, this is up to today, this lab. So in this lab, digital image processing lab, you know how to actually work with images in MATLAB. You know how to import an image, what different things actually represent, what the image actually represent, how to convert the image, from one type to another, then how to perform different small operation on the image, very simple operation. Then you know how to segment an image. Okay, how to perform thresholding, different types of thresholding for different types of images. Okay, you also know how to work with the different apps like the image viewer app, image segmenter app, color thresholding app. There are other apps. You can also try to look at this by yourself if you are interested. Also, you know how about image histogram. What is a histogram, image histogram, how to actually work with image histogram. So this actually falls under image enhancement technique. I have showed you some of them, like the contrast adjustment, histogram equalization, and gamma correction, things like that. So other things, hopefully, if you have digital signal processing course, in that course, I hope that you will learn about more advanced image enhancement technique there. Okay, any question? Any question? If you do not have any questions, let me finish this lab today. Okay, try to practice those things, whatever I have taught you here, whatever is in your lab manual, try to do those things by yourself. If you don't try it in your own MATLAB, you will not be able to do it properly. So try everything by yourself with your own image. Okay, take one image randomly from your phone and try to do it by yourself. Okay, if you face any problems, let me know in the Google Classroom, or you can email me. Acha. So for whoever is actually present here, please write your ID. Write your own ID in the chat. Quickly.
Sir, 3